Hello and welcome to Investment Insight. Before we begin, make sure to subscribe and hit the like button. Now let's break down what's happening in the markets today in a clear and simple way. Imagine a future where the artificial intelligence revolution isn't won by some brilliant software coder sitting in Silicon Valley, but by an electrician laying thick copper wire thousands of miles away.
Right, which is a wild shift in perspective.
It really is. Today, we're taking a deep dive into a development that is fundamentally going to change the physical hardware running basically every single app you use on your phone. We are unpacking South Korea's staggering new AI and semiconductor mega project. And this was officially announced just recently, on June 29, 2026, by President Lee Jae-young.
Yeah, and to really grasp the global tech landscape right now, understanding the sheer scale and the specific timing of this blueprint is essential. We often get so caught up in our local narratives that we miss these massive global pivots.
Absolutely. And for you listening at home, especially if you're an American investor who's just starting to map out the broader global economy context, is everything here. Right now, under the Trump administration, the domestic news cycle is completely dominated by this push to bring manufacturing and supply chains back to American soil.
Right, the whole reshoring movement.
Exactly.
Right.
But while that's taking up all the local headlines, South Korea just laid out a national blueprint that is going to directly dictate the cost and the capability of the global tech economy. So what is our mission for this deep dive?
Well, our goal today is to look past those flashy, trillion-dollar headlines that naturally grab all the attention. According to recent analysis, South Korea is completely redrawing its industrial map. They are attempting this massive structural transformation.
Meaning they aren't just going to be exporting chips anymore.
Exactly. They're moving from a country that historically just manufactures and exports computer memory chips to building a fully self-contained end-to-end AI infrastructure platform.
Okay, let's actually start with those flashy numbers. Because, man, the media reports have been throwing around figures that sound completely wild. And if we don't separate the PR vision from the actual financial reality, it's impossible to understand what's really happening.
Yeah, the numbers do get pretty muddy.
We really need a factual baseline before we dig into the engineering side of things.
For sure. So recent financial analysis shows a headline figure of $1.3 trillion,
Okay.
which is about 2,000 trillion Korean won, just plastered across the news. But that number represents the combined long-term aspirations for conglomerates like Samsung and SK Group, stretching all the way to the year 2040.
Wow. 2040.
Right. It bundles in potential future expansions, theoretical R&D budgets, and domestic investments that haven't even been fully approved by their boards yet.
So it's basically the equivalent of a corporate vision board. If you tell your friends you're going to spend $100,000 renovating your house over the next 10 years, that sounds great.
Yeah, it's a nice story.
But signing a $20,000 contract today to remodel the kitchen, that is the concrete reality. As an investor, you want to see the immediate capital expenditure, the actual money hitting the balance sheet right now.
Exactly. And based on the official reports released on June 29th, the actual immediate concrete capital expenditure plan is $518 billion, or roughly 800 trillion won.
Which is still just a staggering amount of capital. Over $500 billion actively being deployed.
It's massive, and the official blueprints show exactly where that $518 billion is going. It's dedicated specifically to building 4 new megafabs semiconductor factories, 2 for Samsung and 2 for SK Hynix. But the really critical structural detail here is the location.
Right, because they are building these 4 megafabs entirely in South Korea's southwest region. And that location detail is exactly what initially confused me.
Oh, really? How so?
Well, South Korea already has these massive, highly efficient tech hubs right near the capital region of Seoul. They have logistics, the roads, the established workforce. Why go through the multi-billion-dollar headache of migrating the entire industry all the way down to the southwest? Moving heavy industry is incredibly expensive.
It is, but making advanced AI chips isn't like building a standard car assembly line where you just need, a flat piece of land and a highway. According to the research, semiconductor fabs require an absolutely flawless, uninterrupted supply of 2 critical resources.
Okay.
Ultra-pure water and ultra-high voltage electricity.
Let's break those down, starting with the water. Because why does a computer chip factory need so much water in the first place?
So semiconductor manufacturing involves printing microscopic circuits onto silicon wafers. If even a single microscopic particle of dust or a stray mineral touches that wafer, the entire chip is totally ruined.
Oh, wow. I had no idea it was that sensitive.
Yeah, so they have to wash the silicon repeatedly using ultra-pure water. And this is water that has been aggressively filtered and stripped of absolutely all minerals, ions, and bacteria. It takes massive amounts of raw water to produce just a steady stream of ultra-pure water.
And I'm guessing Seoul doesn't have that kind of water to spare.
Exactly. Data shows the capital region around Seoul simply does not have the watershed capacity left to support 4 new megafabs.
So they are literally physically out of water. Okay, what about the electricity issue?
The capital region's power grid is completely saturated. These fabs house extreme ultraviolet lithography machines. And these are the machines that actually print the circuits. Each one requires a massive amount of power.
Just to run the machines themselves.
Well, to operate them, yeah, but also to maintain those immense clean room environments we just talked about. The official reports indicate that the capital region has reached its absolute limit in terms of power transmission. There's just no more room on the grid.
It's essentially the physical limit of the infrastructure. It makes me think of living in an old apartment building.
Oh, yeah.
Yeah, like if you have the AC running and the microwave is on and then you try to plug in a heavy-duty space heater, you trip the circuit breaker.
That's a great analogy.
The house simply cannot carry the current. South Korea's power grid around Seoul is basically at the point where plugging in one more factory will literally trip the national circuit breaker. So they're forced to move to a different region in the southwest just to find a socket that can actually handle the load.
That's exactly it. But moving to the southwest region introduces a whole new set of massive execution risks. You can't simply lay a concrete foundation and expect the factory to work.
Right, you need all the infrastructure.
Yeah, you have to lay entirely new ultra-high voltage power lines across the country, which historically takes years of environmental reviews and construction.
Yeah.
You have to build out new dedicated water treatment facilities.
Plus, anytime you deal with infrastructure on a national scale like that, you inevitably run into local politics.
Oh, heavily. Official reports highlight criticism that choosing the Southwest region is tied closely to President Lee Jae-myung's political base rather than, pure raw economics.
Which is interesting.
Yeah, and we are looking at this impartially, of course, but investors track that political friction as a tangible execution risk. Local municipal permitting can drag out for years if the national and local governments clash. The execution timeline is the real test of this $518 billion investment.
Okay, but even if they pull it off, moving the fabs to the southwest only solves the creation of the chip, right? Once those memory chips are actually manufactured, turning them on creates a completely different crisis.
That's the second half of the story.
Right, because if South Korea is migrating their factories just to find enough electricity to make the chips, how on earth are they going to handle the energy demands of the second phase of this mega project, the actual data centers?
Well, you're looking at a huge pivot to domestic AI data centers. Historically, South Korea operated on a very straightforward export model. They manufactured the memory chips, loaded them onto cargo planes, and sold them to U.S. tech giants.
And then those U.S. giants plug those chips into data centers located in America or Europe.
Yeah.
So the U.S. companies dealt with the massive power bills and the server cooling.
Exactly. But the recent analysis indicates a profound structural pivot. South Korean conglomerates, specifically SK, GS, and Nover, are heavily investing to build domestic data centers now.
Oh, so they're keeping them at home.
Yeah. We're talking about an initial separate investment of over $400 billion to construct 8.4 gigawatts of AI data center capacity right on South Korean soil by the year 2028. They no longer want to just export the pickaxes, so to speak. They want to run the gold mine internally.
8.4 gigawatts. I mean, we hear the term gigawatt thrown around a lot in tech news, but the sheer physics of that number is hard to grasp. What does 8.4 gigawatts actually demand from a country's infrastructure?
To give you a real-world equivalent, 8.4 gigawatts is roughly the total sustained power demand of an entire small country.
Wait, really? A whole country?
Yeah. And AI data centers run incredibly hot. Pushing that much electricity into thousands of densely packed server racks generates extreme heat.
Which means the actual bottleneck for the future of AI isn't the software code at all. It's the plumbing and the electrical engineering.
100%. Based on the research, accommodating that 8.4 gigawatts requires a total overhaul of South Korea's electrical grid technology. They just cannot rely on traditional power delivery.
So what are they changing?
The blueprints show a massive transition toward high-voltage direct current, or HVDC systems.
Okay, why direct current? I mean, our entire modern grid runs on alternating current.
Because alternating current loses a significant percentage of power as it travels over long distances. When you are dealing with 8.4 gigawatts, you literally cannot afford that transmission loss. HVDC pushes electricity far more efficiently from the power plant directly to the data center.
That makes sense.
Furthermore, the reports show they're investing heavily in solid-state transformers. Traditional mechanical transformers simply cannot handle the rapid, massive load spikes that AI data centers demand without literally melting or catching fire.
Melting. That's terrifying.
It is. So solid-state transformers use semiconductor materials to digitally manage and step down that extreme voltage safely.
It really fundamentally changes how you view the artificial intelligence industry. We always think of AI as this sleek, weightless software business. But the data shows it's actually a heavy utility and heavy construction business.
Completely.
The true beneficiaries of this boom might not just be the chip designers, but the industrial companies manufacturing cooling towers, copper cabling, and these HVDC converter stations.
And that leads directly to the third pillar of this blueprint. Because if South Korea is completely overhauling their grid to power 8.4 gigawatts of AI computing, what is their actual end goal? What are they going to do with it?
Right.
The research shows their application of this AI is vastly different from the American approach.
Yeah, because in the US, the consumer focus is heavily tilted toward large language models. We think of AI as a chatbot that can write an impressive essay, generate a picture of a cat, or, automatically draft a polite email to a client. It's a very digital, screen-based assistance.
Exactly. But South Korea's strategy is heavily focused on what industry analysts call physical AI.
Physical AI, I actually love that concept. It's essentially taking the brain of a large language model and putting a hard hat on it.
That is the perfect way to visualize it. Instead of an AI just writing text on a screen, South Korea wants an AI to be the autonomous brain inside a robotic system that is physically operating in the real world.
Oh, wow.
Data shows the goal of this mega project is to deploy highly advanced humanoid and industrial robots across 10 major industries by 2028. And to support this, they are launching a national mobilization to train 10,000 specific AI robotics experts over the next 5 years.
10,000 robotics engineers in 5 years is a massive undertaking. But, it makes perfect strategic sense when you look at the South Korean economy.
Yeah.
They are a legacy global manufacturing powerhouse.
They really are.
They built our cars. They construct a massive percentage of the world's commercial cargo ships. They manufacture EV batteries. And they have a rapidly growing defense export industry.
So they are playing to their sovereign strength. If you look at shipbuilding, for example, it is incredibly labor-intensive. Using physical AI, you aren't just programming a dumb robot arm to do the exact same weld 1,000 times.
Right. It's smarter than that.
Exactly. You are giving the machine vision and AI processing so it can actually look at a massive steel hull, identify metallurgical inconsistencies in real time, and adjust its own welding temperature and speed on the fly.
So they aren't trying to outcode American software companies at all. They're taking their existing dominance in heavy industry and supercharging the margins. A smarter factory means less waste, higher yield, and cheaper production costs.
For sure.
If you're an investor tracking this space, the long-term play here isn't necessarily finding the next subscription software company. It's industrial automation.
Which brings us to the financial reality of this entire project and where the market is currently pricing these companies.
Right, and this is where I am genuinely confused, and I know a lot of our listeners looking at the stock charts are confused too.
Let's hear it.
We have literally just spent the last 10 minutes detailing an unstoppable economic boom. They are spending $500 billion upgrading their national grid and automating massive shipyards. And yet, right after this mega project was announced, the stock prices of the two biggest companies involved, Samsung and SK Hynix, actually dropped.
Yeah, they took a hit.
In what universe does a company announce massive state-backed growth and immediately see its stock punished? It just doesn't compute.
It feels incredibly counterintuitive until you look at the underlying financial mechanics of the semiconductor industry. First, we have to acknowledge the absolute terror they are on right now. Recent analysis looking at just the first 20 days of June 2026 shows that South Korean semiconductor exports skyrocketed by 188.4% compared to the previous year.
So they're exporting almost triple what they were doing a year ago. They are literally selling everything they can possibly produce.
Yes, the global economy is desperate for high bandwidth memory, or HBM chips, which are essential for AI processors. But memory chips, no matter how advanced they get, are ultimately a cyclical commodity.
Okay, let's look at this through the lens of a classic cyclical boom and bust. Let's use the lemonade stand analogy.
Okay, I like that. Let's hear it.
Let's say there's a historic heat wave,
Yeah.
right? Everyone is incredibly thirsty. So setting up a giant lemonade stand makes perfect economic sense. You are going to make a fortune.
Right, the demand is peaking.
But if everyone on your block sees your success, borrows a ton of money, and builds their own massive lemonade stands, what happens? By the time all those stands open 2 years later, the heat wave might have ended.
And you have way too much lemonade.
Exactly. You have a massive oversupply, prices crash, and everyone goes broke trying to pay off the loans they took out to build the stands.
That is the precise mechanism spooking the financial markets right now. The Financial Times reported that investors looking at this $518 billion announcement immediately factored in the risk of severe oversupply.
So they saw the huge investment and got scared.
Basically, yeah. Historically, in the memory chip business, whenever you see massive coordinated capacity expansions, it almost inevitably leads to a massive glut of chips 3 to 4 years down the line.
Because the stock market is a forward-looking discounting mechanism. They aren't looking at the 188% export growth happening today.
No, they're looking ahead.
They're looking at the 4 new megafabs finishing construction in 2028, turning on their machines, and flooding the global market with memory chips, which would cause the price of those chips to plummet.
That massive CapEx burden and the depreciation of those new factories hitting the balance sheet is exactly why the stocks took a hit. But, and this is crucial, we cannot treat SK Hynix and Samsung as identical assets just because they are both South Korean chip makers.
Right.
Based on recent reports, their strategic positions within this specific cycle are vastly different.
Let's break them apart then. Why are their positions so different if they're both building these giant fabs?
Let's start with SK Hynix. Right now, they are the undisputed global leader in HBM high bandwidth memory. To understand why they're winning, you have to understand why AI actually needs HBM. Traditional computer memory works kind of like a massive stadium with only one revolving door.
Okay.
It doesn't matter how fast the AI processor is, it can only get data through that single door so quickly.
Which creates a severe data bottleneck. The processor's just sitting there waiting for information.
Exactly. HBM solves this by stacking multiple memory chips vertically on top of each other, like a skyscraper. And then they punch thousands of microscopic holes through them, which are called through-silicon vias.
Oh, wow.
It is the physical equivalent of knocking down the stadium walls and building hundreds of giant exits. Data flows instantly. SK Hynix mastered this vertical stacking architecture first.
So they have a massive head start.
They are riding the absolute crest of this wave. So much so that reports indicate they're planning a U.S. ADR listing, meaning they will list shares directly in the U.S. market to raise up to $29.4 billion just to fund their expansion.
Going back to our analogy, SK Hynix is the real estate developer who already owns the best fully leased skyscrapers in the city and is just using the profits to build one more.
That's right.
But Samsung is in a very different boat, aren't they?
Yeah, Samsung is historically the undisputed king of standard legacy memory chips. But in the highly specialized HBM space, they missed the initial wave. They are currently operating from a catch-up position.
Which is tough in tech.
Very. Recent analysis shows their CapEx strategy is a complex turnaround story. They are pouring 400 trillion won into a specific fab in Gwangju and investing heavily in a massive specialized packaging cluster in the Chungcheong region.
And advanced packaging is literally how they glue those vertically stacked chips together, right?
Exactly.
So Samsung is being forced to spend hundreds of billions of future. One, not to dominate the future, but just to close the technical gap with SK Hynix today. That massive capital expenditure burden, combined with the risk of catching up just in time for an oversupply glut, perfectly explains why investors are viewing them with extreme caution right now.
It is a high-stakes, capital-intensive race, and the financial markets are ruthlessly pricing in the cost of every single factory being built.
Well, we have covered a massive amount of ground today, stripping away the PR numbers to look at the physical reality of this mega project. So let me provide a quick wrap-up for you listening. The critical takeaway here is that South Korea is no longer content just being an exporter in the global tech supply chain. To secure their place in the AI revolution, they are completely rebuilding their national power grid, migrating massive fabrication plants to the southwest to find ultra-pure water, and deploying physical industrial robots to automate their heavy industries. But for investors, the excitement of nearly 200% export growth has to be balanced against the very real cyclical risk of a massive supply glut hitting the market in 2028 when these factories finally power on.
And if there is a final thought for you to mull over as you watch this sector develop,
Yeah,
we've really been conditioned to view the AI race as purely a software battle.
right. Algorithms and code.
Exactly. We picture brilliant programmers writing the most elegant code. But based on the sheer physical scale of South Korea's $500 billion bet, the ultimate winner of the AI era might simply be the nation that can figure out how to lay the most copper wire, build the safest high-voltage power lines, and secure enough water to cool down the hottest servers before the grid literally collapses. Will the true ceiling of the AI revolution be decided by construction workers, pipe fitters, and electricians, rather than software developers? It really forces you to completely reevaluate what an AI company actually looks like.
It really does. It brings the cloud out of the sky and anchors it firmly in concrete, copper, and water. Don't forget to subscribe and hit that like button.